Hello viewers, welcome once again. I am your teacher Jeff and it's math. The topic is trigonometry 3. It is a Form 4 topic and a continuation of several topics. In Form 2, there was trigonometry 1. In Form 3, there was trigonometry 2, then trigonometry 3. And there should be another trigonometry in the same Form 4 class, but in the name of three-dimensional. That's later on. Okay, so by the end of this topic, the specific objective should be, at least you should remind yourself what you did in Form 2, referred to as the trigonometric ratios. Then you should also learn how to derive an identity, a trigonometric identity, in the relation sine squared theta plus cos squared theta equals to 1. Then later on in the topic, there will be application as far as trigonometry as far as trigonometric functions or rather graphs are concerned. So those are some of the few things that you have to look at before you actually finish the topic. So today, it's a bit of introduction and maybe just little parts on deriving the identity I talked about and maybe some small application of that in simple expressions. So that's what we are going to look at today. But before all this, there is the trigonometric ratios. In Form 2, you were told that if you have a right angle triangle, whereby an unknown angle, let's say this angle, an unknown angle, we call it theta. So if this is a right angle triangle whereby this is theta, this is normally referred to as the adjacent, the opposite, and the hypotenuse. The three sides of a right angle triangle. That side which is close to theta is the adjacent. Opposite to theta is the opposite. Then the longest side is always the hypotenuse. So now, from this right angle triangle, you introduced to three ratios, which were the sine ratio, the cosine ratio, and the tangent ratio. The ratios were a relation which helps you either find a side or an angle on a right angle triangle, provided you're given some extra information to do so. So this is what you're told. You are told the three ratios, starting with sine. You had this relation, sine theta equals to opposite over adjacent. It means the relationship is between theta, opposite, and adjacent. That's for sine. Cos theta equals to adjacent over hypotenuse. Then there was a tan theta, which is equals to opposite over adjacent. From your Form 2, you should know this in details. I don't think as a Form 4 there is time to go very much deep into this, explaining every part. You should have an idea of what I'm explaining about. So there was a general form of all this, just to summarize, which was in the form so, ka, then toa. So katoa, representing the three ratios. So is for sine theta equals to opposite of hypotenuse. Ka was cos theta equals to adjacent over hypotenuse. Then toa, which is tan theta equals to opposite over adjacent. So I'm very sure that anyone who is in Form 4 is very much familiar with this. Now, that said, I said that you have to know these three ratios because eventually what you'll do, maybe we might require some information to do with them. So try as much as you can. If you know them, then that's it. Well and good. Still on a right angle triangle, you should be familiar that anytime there is a right angle triangle, for a student, you should either think of Pythagoras theorem or SOHCAHTOA, the one that I just mentioned. So for Pythagoras theorem, if this is a right angle triangle, then this is adjacent, opposite, hypotenuse. Then the relationship as far as Pythagoras is concerned in this question should be a squared plus b squared, sorry, not b, o squared equals to h squared. This is the relationship between the three sides on that right angle triangle. Now, what I want to explain here should clearly lead us to what I've already mentioned, and it is the relation sin x squared plus cos x squared equals to 1, which can be referred to as one of the many trigonometric identities that you will learn maybe later on, but in this syllabus, it's only this one that we're mentioning. So now, from this statement here, I want to do this. Divide all sides by h squared. If I divide this by h squared, and h squared, I will get a over h bracket squared plus o over h bracket squared, then equals to 1. Now, I want to compare this with what I had already explained before. So there is some place we said there is a ratio a over h, and it's actually here. A over h is represented by the ratio of cosine. So I can replace this statement with a cos, then squared, because there is square here, theta plus, you see, it's a over h, and a over h is the same as cos. So this statement here is the same as cos, but then there is a raised to 2. So if it's raised to 2, you can rewrite this statement as cos squared theta. O over h, sorry, this was h, how did I write a? Okay, O over h represented the ratio sign. So this statement can be rewritten in the form, instead of O over h then squared, O over h is the same as sine. So I can write this as sine squared theta, then equals to 1. And that's the relation we are talking about. So the relation we have been introduced to, which is a trigonometric identity in this case, is cos squared theta plus sine squared theta equals to 1. This relation is a very important one as far as trigonometry 3 is concerned. There is so much application of this in both expressions on trigonometric, in trigonometry and also in equations. So always note that if I have cos squared theta plus sine squared theta, the value should be 1. Now let me just look at this maybe in details and how you need to look at it. So when you have an equation where there's something on the left, right, it means this is just equivalent to this. So then if this is true, what it means is in this topic, anytime I'm working out questions, then I come up with a statement like cos squared theta plus sine squared theta at the end, or somewhere within the equation I'm doing. Then I should know that maybe, if I wish, I can replace that statement with 1. So instead of that, I'll simplify it. Instead of writing that value, I change it, replace it with 1. Or in the same topic, you might come across questions where 1 is involved and you're supposed to simplify or something. Then instead of that 1, you might be required to change 1 with this statement here, cos squared theta plus sine squared theta, for you to be able to continue with the calculations or something. So this statement here means anytime you see this, you can think about this. Or in the topic, if you see 1, in terms of simplifications, you can think about this statement here. Okay, there are other 2 versions of this that might be very necessary in the topic. And the first one being, from this statement, we can rewrite from some other 2 equations. Making cos squared theta the subject, I'll have cos squared theta equals to 1 minus sine squared theta. That's the first. What does it mean? It means anytime I see cos squared theta in this topic, maybe, and I'm simplifying things, I can think of rewriting that statement cos squared theta with this. Or anytime I have 1 minus sine squared theta in this topic, I'll also think of rewriting or replacing this statement 1 minus sine squared theta with the statement cos theta. A very important thing. It's either you have this, but you need this, or you have this, you need this. So you just look at the question and see how it's asked and how you can deal with it. We'll do examples later on. It will maybe now make sense because right now I'm talking about things that some students may be wondering what I'm talking about because you don't know what are these things that you are changing. So cos squared theta equals to 1 minus sine squared theta. If I see this, it is just the same as this. Or if I see this statement here, it's just the same as this. So I can replace. Depending on the conditions of the question, you might change so that it fits what you may be required to calculate. Okay, the next one is if I made sine squared theta the subject, then I'll have sine squared theta equals to 1 minus cos squared theta. Just the same thing, like I've explained in the previous part. You see, sine squared theta is equally the same as 1 minus cos squared theta. So if I see this, I may replace with this. Or in some questions, when I see this, I may replace this statement with this here. So just as simple as that. It's knowing how these values relate and how I can use them to have something that will help me in the next calculations. So this identity here, or the relation between these values, just make sure that you know this statement clearly. You also know this, and you also know this. And then, once you know them, you can actually now apply them in whichever questions that will be asked. And that's what we're going to do. Like I said today, it's simply, we want to focus on this main thing. Let's familiarize with this relation there and see how we can use it in just expressions for today. Then when it comes to questions where it will mostly be used maybe, then it should be clear by that time. Okay, now, before we put this relation in application, there is also one thing that might be very important that I want to remind you, and that's from your Trigonometry 1, Form 2. And it is, in Form 2 you're told, there is a relationship between sine, cos, and tan. I'm very sure that for most Form 2s, they talked about the relation, but never used or never applied in any questions as far as Form 2 is concerned, because it wasn't really used. And the relation was sine theta over cos theta equals to tan theta. Anytime you have a constant angle, let's say 40 degrees, if you say sine 40 over cos 40, the answer you get is just the same as tan 40. That's what we mean by this. So sine 40 over cos 40 equals to tan 40. So there is this relation. It's a very important one in so many ways. In Form 3, mostly in Form 4. In Form 4, we use more of this. And remember, for the same statement, it might mean if you squared, still be the same. It can also be sine squared theta over cos squared theta should be the same as tan squared theta. If it was cube, it will still be the same, provided we are talking about the same angle in any of the cases. So it can even be sine raised to 5 theta over cos raised to 5 theta equals to tan raised to 5 theta. So now, to add on the relation I just explained, I also add this, sine theta over cos theta equals to tan theta. That. So now, with those two, the relation between the two values there and relationship between sine, cos, and tan will be used to simplify some of the questions that I'll talk about in this case. Now, how do you simplify expressions that require this information? How will the question be asked? And that's what we'll do, starting from the very simplest examples ever you can get. So the question will be simplify. It is simply simplifying values. So you'll be asked simplify. Then something like 7 minus 7 cos squared theta. It's simplify. So to simplify this, look at it. In simplifications, I think if you talk about expressions, you should know that in most cases, expressions can be simplified by either factorizing, expanding, and maybe doing some other things depending on the type of topic you're dealing with. So now, this is an expression. I want to simplify it. And I have to use maybe something on what I've explained there. The first thing I'll do is factorize. I can see 7, 7. So I'll factorize 7 out, which will be 7 into 1 minus cos squared theta. Okay, look at that. If you look at this carefully, you notice there is 1 minus cos squared theta. I didn't wrap this because I wanted to explain so that you can see 1 minus cos squared theta, we said that that value can be replaced by sine squared theta. So what it means by this, I was simplifying. Instead of this statement, I'll replace it with what it's equivalent to. So the final answer should be 7. Instead of 1 minus cos squared theta, then I'll have sine squared theta. That is it. So I've simplified this, and the final answer is this. What did I use? This relation here. Next example. Next example, how about if I had a question like 25 minus 25 sine squared theta, then square root. So there is a square root involved. If you're careful, what's inside the square root is what I had explained in the previous example. So the only change here is the square root side. So now, I want to simplify this. How do I do it? This simplified should be, first factorize what is inside the square root side. So this should be 25 into 1 minus sine squared theta. Then the square root. And number 2, there is 1 minus sine squared theta. This value can be replaced according to my explanation that I had before. 1 minus sine squared theta is the same as cos squared theta. So then this should be 25 cos squared theta. But remember, there is a square root. Okay, then the square root of 25 is 5. The square root of cos squared theta is a cos theta. So the final answer for this expression here is supposed to be this, simplified. I hope the explanation is clear. Next example. Next example. You see, the first example I used, brought in the next question, which relates to the first example in a way, but the only difference has been, in this case, there is an addition of square root. Then I've used the square root in the final part to get the value that I got there. Okay, so the next example is, square root of 9 minus 9 cos squared theta over cos theta. Okay, the difference is, for this question, I can see there is a denominator to add on exactly a concept I've already explained. So now the 2 values here, but looking at the question, most calculations should be in this because I don't see anything to simplify here. So I focus on the numerator, and this numerator will be the same as 9 into 1 minus cos squared theta. We know that. Then over cos theta. Then 1 minus cos squared theta, from what I've already explained, should be the same as sine squared theta. So this statement will read 9 sine squared theta over cos theta. But there is a square root. This simplified further, the square root of 9 should be 3. The square root of sine squared theta should be sine theta. Then over cos theta. Okay, for someone, you might think that this is the final answer. Yes, you have simplified, but looking at the question carefully, maybe the simplification is not really complete. So you look at what you have done, then think, what did we say? I told you that in Form 2, you were taught the relation sine theta over cos theta equals to tan theta. So once I have this here, and I see that, then it means I can further simplify this to another different value. So sine theta over cos theta is the same as tan theta. Then the overall final answer I'll have for this should be 3 tan theta. That's it. So notice this and what I did. If you leave this as your final answer, it's not really complete. Your simplification is not complete. So you have to check, always check the final. The next example will be 8 sine theta over the square root of 4 minus 4 sine squared theta, which is not very much different from the other example, the previous example I just explained. It's almost the same thing, just the same, because it's simply simplifying, check what you can replace with what, and that is it. My numerator has not that much of simplification, so I'll focus mostly on the denominator. So this statement here should be the same as 8 sine theta over a in my denominator. There is 4 into 1 minus sine squared theta. Then 1 minus sine squared theta is the same as cos squared theta. So this statement here, I'm writing the whole statement. It will be 8 sine theta over 4 cos squared theta. I've just changed this to cos squared theta. Then there is that square root sign. So then from this, I simplify this further, which will give me 8 sine theta over, that's the numerator, then the denominator, square root of 4 is 2. Square root of cos squared theta is a cos theta. Again, 8 divided by 2 is the same as 4. But there is sine theta over cos theta, which is the same as tan theta. So the final answer for this should be 4 tan theta. That is it. Okay, next example. Next example is 1 plus tan squared theta. Okay, look at this carefully. Now there is tan squared theta. I already mentioned that anytime you see tan theta, think of maybe sine over cos. Or if you see sine over cos, think of tan, because that's how they relate. So once there is tan squared theta and I've been asked to simplify this, the only way I will simplify this is change this in the form sine squared theta over cos squared theta. So this should be 1 plus sine squared theta over cos squared theta. Then again, what I have here is just two numbers, fractions added together. When you have a value like, before I do this, if you have a number like 3 plus 1 over 7, how do you do this? You look for the LCM of 1 and 7, then the normal way you solve to get the final answer. So for this question, I have 1 plus sine squared theta over cos squared theta. I'm simplifying. I'm not yet done. Long way to go. So the next thing you'll do is get the LCM of 1 and cos squared theta. And the answer should be cos squared theta. The next, cos squared theta divided by 1. The answer is cos squared theta. Then times 1. The final answer, cos squared theta. Plus cos squared theta divided by cos squared theta. The answer is 1. 1 times sine squared theta, it should be sine squared theta, which is equals to. Okay, look at this question carefully. You notice that there is a cos squared theta plus sine squared theta. But what did we say? We said cos squared theta plus sine squared theta equals to 1. So that said, it means that instead of cos squared theta plus sine squared theta, I replace that by 1, then over cos squared theta. And that's my final answer. in that case. Before I show the next example, I will, because I've just explained this and I want to ask you to do something relating this, but maybe with the numbers involved in numerator and the denominator. So I want you to try at your own free time cos raised to 4 theta over 1 plus tan squared theta. So try doing that. I'll want to see the answer that you'll get in this case. Okay. And maybe think the answer should be something cos raised to 6 theta. So if you're able to get this, maybe what you'll have done is correct. Next example. The next example is cos raised to 4 theta minus sine raised to 4 theta. Now you're supposed to simplify this. It isn't. It looks maybe weird, but maybe it's the easiest, in fact. So if you have to simplify this, there are some questions that will require you to always remember the concept difference of two squares. That's trigonometric identities form 2. There were 3. There was a difference of two squares as one of them. A statement like if you have a minus b, then a plus b. This expanded should give you a squared minus b squared. So in difference of two squares, for most questions you'll have this form, whereby you are required to factorize and get the factorized form, which is this. So what are the characteristics of a difference of two squares expression? This is how it should be. The first number should be a perfect square. The next number should be a perfect square, and the sign in between them should be a negative sign. So now, if you want to factorize a perfect square, you simply say the square root of this, which is a, minus the square root of this, which is b. Then repeat this statement with a plus sign. Which means if I had a number like x raised to 2 minus 4y raised to 2, then I want to factorize this. First, I'll check if it's a perfect square. Indeed, difference of two squares. Indeed, it is, because this is a perfect square. The sign in between is negative. So the square root of this is x. The square root of this number is 2y. Then it will be this, then repeated x plus 2y. Change in signs, but the same values. One more example before I do that, because it's very necessary that you notice that sometimes when you learn these things in previous classes, you might need them later on. And we have used some simple examples like this relation there. You did it in form 2, maybe you never used it as much, but now it has been put into use. One more example, if I had x raised to 4 minus 1, is this difference of two squares? Yes, because this has a square root, this has the sign in between them, minus. So the answer for this should be x squared minus 1, x squared plus 1. But this is not factorized fully, because this can also be difference of two squares. And the value of this should be x minus 1, x plus 1, from the rules that I already explained. That. So once you simplify this up to this form, it is fully simplified. This is it. So notice difference of two squares. For most questions in algebra, in one way or another, things end up being difference of two squares. So here, just use the same. So this is difference of two squares because of what I've explained. The square root of this is cos squared theta. The square root of this is sine squared theta. Then brackets cos squared theta. Repeating the same with now the different sign. So look at it. Anytime you are simplifying, try to look at what you have simplified if it's in the most simplified form. Or if there is anything else you can do, you proceed. Now, looking at this looks like another difference of two squares. So this as difference of two squares is the same as cos squared theta oh, not cos squared theta, but the square root of this is cos theta minus sine theta. I'll repeat the same, cos theta plus sine theta. Sine theta. But then this statement here is not difference of two squares. But based on what I had explained in the first law, the first relation, cos squared theta plus sine, it was supposed to be sine squared. Cos squared theta plus sine squared theta is the same as 1. So then this statement here is just 1. So then when you simplify this, it will end up being this and this, which is cos theta minus sine theta, cos theta plus sine theta. That is it. Okay, just to finalize, because I've explained almost everything I needed for the introduction, and as far as that relation is concerned and expressions, maybe at your own free time, you can try working out this for me. The first question is 1 minus cos squared theta over 1 plus cos theta. For this, I'll give you the answer. So just try and make sure that when you solve it out, you get this answer. So the answer should be 1 plus cos theta. Try to work out the question until you get this value here. Then the next one, second question I want you to do later on is tan theta over 1 plus tan squared theta square root. So try to work out these two questions, and I think that will be enough for the introduction trigonometry, but most of the work which involves equation will be in our next topic. Thank you for listening. Meet you next time.